Hi, I'm Dr. M, and today we are going to talk about ICD-10 PCS guideline. But before we dive into that, we will quickly look into a few important ICD-10 CM guideline just to set the foundation. And even before that, we need to understand something bigger, that is what's happening in medical coding right now, AI, automation, because if we don't understand this shift, we won't really understand where we stand as coders, and more importantly how we can stay relevant. So let's break this down very simply. First, RPA, robotic process automation. This was the starting point. It was the first layer. It handled tasks that were highly repetitive, rule based, and predictable. Things like copying patient data, moving information between systems, basic claim workflows, no interpretation, no decision making, just execution. Then came CAC, computer assisted coding. This is where things started getting interesting. Now the system could actually read documentation, analyze clinical terms, suggest possible codes, but still it was not independent. It needed us to validate, to confirm, to finalize. So the control was still with the coder. Now we are moving into autonomous coding. And this is a big shift because now the system doesn't just suggest, it start deciding. It can assign code based on pattern, based on historical data, based on guideline. And this is important. This is not something in future. It's already being implemented. And beyond that, we are moving toward agentic AI, where system don't just assist, they act, they can interpret, validate, execute the workflow with very minimal human input. So now the real question is, where do we fit in? Because if we are being honest, AI is extremely powerful. It can process massive data, remember guidelines, recall code faster than us, and it will continue to improve. But this doesn't mean we become irrelevant. Think about something very simple, like writing an email. When we write an email, the idea, the intention, the context, what we actually want to say, that come from us. AI doesn't decide that. What AI does, it just give it a better structure, refine the language, and make it sound more polished. Okay, and that definitely help. But the thinking, the intent, the context is still human, and that's exactly the difference. AI work on pattern, and we think, we interpret, we understand the clinical context, we connect information. That is not directly written, that is clinical judgment. So our role is not to compete with AI, it's to work with it. If something is repetitive, AI can handle it. But when it come to interpretation, decision making, clinical reasoning, that part is still ours. So that's exactly what we are going to focus on. Not memorizing codes, not trying to remember anything, but understanding how to think through coding. So first, let's quickly look at few important ICD-10 CM guideline, and then we will move to ICD-10 PCS, where the real application begin. Okay. Okay. So now we have understood where we stand with AI. Let's move to something more practical, ICD-10 CM. Now, we are not going to go very deep in CM today because this itself is a very large topic, and I have already covered principal diagnosis, secondary diagnosis, and admitting diagnosis in detail separately. So, if you want to understand this topic deeper, You can watch that video after this. But for now, we will focus on few key ideas here that directly impact how we code. Okay. The first concept, very important in coding, we don't code what we think, we code what is documented. It sounds very simple, but this is where most mistake happen. Sometimes clinically, when we feel a condition is present, there may be even indicator, but if it's not documented, we don't code it. We What we can do, if we see the clinical indicators, we can raise queries, okay, to the provider. We cannot code anything that is not documented. This is like if someone asks you, is coding based on clinical indicators or documentation? Blindly just say coding is based on provided documentation. Indicators support diagnosis, but they won't determine the coding. Okay. So the next concept, it's a very practical. Exclude one and exclude two. Exclude one means these two doesn't exist together. These two condition cannot exist together. So if one code is used, the other is not allowed. Exclude two is different. It means the condition is not included, but both condition can exist together. So in simple terms, exclude one is never together, exclude two not included, but possible together. Okay, I have attached the definition here. Okay, so you can refer that. Now, another important concept, sequencing. We don't decide based on what sound more serious. We decide based on why the patient was admitted, the reason for admission, and it drives the sequencing. That becomes the principal diagnosis. There is admitting diagnosis, then there is principal diagnosis. One often mistake between the two, but if you want to clear version, you can just refer to the video. Okay, let's take some example. Patient has atrial fibrillation and myocardial infarction. Now, what do we choose as principal? This is where confusion happen. We don't look at name, we ask which condition required more work, which condition drove the admission, and that become our principal diagnosis. Okay, one more important concept, COVID coding. We only code confirmed cases. If it's suspected or ruled out, we don't code, we code the symptom. Confirmation is key. Okay. Next, HIV coding. If a patient is HIV positive but with no symptom, we assign Z21. If patient has a HIV related condition, we assign B20. And very important, once B20, always B20. We don't go back to Z21. So if we step back, what is ICD-10-CM really is? It's not about memorizing code, it's about understanding documentation, thinking about sequencing, and identifying what really matters. And now, once this clarity is there, we move to the real system, ICD-10 PCS. Here, thinking truly begin. Now, one important shift here, ICD-10 PCS is not list of code, it's a system. It is designed to describe exactly what was done. And once we understand that, everything become very, very easier. So if someone asks what ICD-10 PCS is, it's procedural classification system designed to capture procedure in a structured and detailed way. Okay. So this system is built on one idea. Each character has a meaning. Each character represent a specific aspect of the procedure. So instead of memorizing code, we just answer questions. Every PCS code has 7 characters. Each character answer one question. Let's go through this slowly. First character, section. Which type of procedure is this? Medical, surgical, imaging? If this is wrong, we are in the wrong system completely. Character 2, body system. What are we working? Liver, heart, skin. So if someone asks what is body system, you can say it defined the general physiological system or anatomical reason. Now, third character, root operation. This is the core, this is the dish season. Like root operation represent the objective of the procedure, not the name, not how big the surgery was, just the objective. Let's test this. If something is removed, is it enough? No. We need to know part or whole, tissue or fluid. Only then we decide the root operation. Now, fourth, body part, more specific location, not just liver, which part of the liver. Then the character five is about approach. How did we reach the site? Approach is the technique used to represent the site of the procedure. Difference between open and percutaneous, it's based on exposure, not on incision size. Okay. So now the character sixth, device. A device is something that remains in the body after the procedure. Temporary tools doesn't count. Okay. So character 7, qualifier. It's the last, it's the extra detail. Something is important, something is not. So if we step back, this is not complicated. It's just structured thinking. We are answering question, what was done, where was it done, how was it done. If you understand this, you don't need to memorize PCS code. This is important. We don't go wrong because we don't know PCS. We go wrong because we jump to the code too fast. We read the procedure name and we assume. But PCS doesn't care about the name, it cares about what actually happened. So the structure gives us the framework, but the real decisions start here when we try to answer what was actually done, what, and that brings us to root operation. Let me slow down here. So now we come to the core, root operations. This is where coding actually happens, and not in the code, but in this decision. Now, before we go deeper, let's just connect this to what we have discussed earlier, body part in PCS. So, body part in PCS is not exactly anatomy, it is a defined value. And because of that, root operation changes. Okay. So, we have actually discussed this in earlier video how PCS body part is different from what we learn in biology and how that directly affect how we choose the root operation. So if you want to go deeper into that, you can go through that video, but let's connect it here quickly. Take lung. If a lobe is removed, what do we think? Part removed. So excision. But no. In PCS, a lobe is considered as a complete body part, so removing a lobe is actually resection. This is where PCS thinking changed, not because of how we feel, but based on how PCS defines structure. Now, come back to the root operations. Root operation represent the objective of the procedure, the intent, what surgeon wanted to do. Everything depend on this, okay? So instead of remembering definition, let's build a decision path. What was done, what exactly was affected, and what was the intent. So now let's see the group. Group 1, excision. Excision. Excision means cutting off or out without replacement a portion of body part. Keyword portion. If part of liver is removed, even if it's large, it is still excision. Resection. Resection means cutting out or off without replacement all of a body part. Keyword here is all. If 90% is removed, what do we think? Resection? No. If anything remains, it's still excision. Extraction. Extraction means pulling or stripping out or off all or a part of body part. Key difference? Method is pulling, not cutting. Destruction. Destruction means physical eradication of tissue without removal. Important is tissue is destroyed but not taken out. Excision, cut plus remove. Resection, cut plus remove all. Extraction is pull and destruction is destroy, not removal. Putting in or taking out. Insertion. Putting in a biological device. Removal. Taking out a device. Replacement. Taking out and putting in a similar device. So, what is the difference between insertion and replacement? Replacement involve removing first. Okay. So, now we will see the group 3 separation. Division. Cutting into a body part. What is release? Release is freeing a body part from abnormal constraints. See, division is cutting, release is freeing. Now, the fourth group, drainage and inspection. Drainage is taking or letting out fluid or gases. Inspection is visually exploring a body part. If the scope is used, it's still inspection. Now, here's where the things get real. Documentation doesn't say this is excision, it described it. So we interpret partial kidney removed laparoscopically. What was done? Part removed, so excision. How? Percutaneous endoscopy. So abscess drained. What was removed? Fluid. So what it is? Drainage. Tumor burned using laser. No tissue was removed, so it will be destruction. What we do, we read very fast, we assume, we match word. So, but PCS doesn't work like that, it require interpretation. We know this, but we don't always apply all these things. So again, before coding, just ask what was done, how it was done, why it was done. So now we understand what was done. Next question became how it was done. Okay, I hope this helps you and you are able to understand it now, the difference. So, thank you for watching and keep revising your core concept, keep sharpening your thinking because it's not about memorizing all this, it's always about understanding the logic behind them. I will see you in the next one. Thank you.